Interior and exterior angles. So recall that the sum of the interior angles of a triangle is 180 degrees. And the sum of the interior angles of a quadrilateral is 360 degrees. So what value do you expect for the sum of the interior angles of the polygon displayed below? So there's a couple of different ways that you could approach this. Well, we know that a triangle is 180 degrees. We know that a quadrilateral can be broken up into two triangles. So 180 degrees plus 180 degrees is 360 degrees. So how many triangles can we make? So this was two triangles. So this is one triangle, and this is two triangles. How many triangles can we make in this shape? We can make one here, and then we can make one there and one there. So the minimum set number of triangles that we can make here is 3. So what is 3 times 180? Well, that's 540 degrees. So that is a good strategy to help us think about that. So what conclusion can you make about the sum of interior angles of a polygon? Well, we want to think about breaking it down into the minimum amount of triangles it makes and then multiplying that by 180. And it even goes down further to think about a formula, which we're going to look at a little bit later. So what conclusion can you make about the sum of the interior angles of any polygon? So you can make, or I'm going to say break the shape up So break this shape up into the minimum amount of triangles. Then times that number by 180 degrees. Because we know that the angles inside of a triangle equals out to 180 degrees. There is, like I said, there is a formula though, a formal formula that we are going to take a look at in a little bit. So now we're going to construct what we call exterior angles. So exterior angles is if I draw a straight line, this is the angle that would be formed on the outside of that line. And I can do that for each of these lines. So I can draw straight lines so that I can find out what these angles might be. So I'm going to call this one A, this one B, and this one C. So how do we find out those exterior angles? Well, we have to figure out what the supplementary angle would be, because we know that these add up to be 180 degrees, right? So A is the same as 180 degrees. Take away 75, so A is equal to 105. We can do the same thing for B. B is the same as 180, take away 40. So B is the same as 140 degrees. And same thing with C. C is the same as 180, take away 65. And that's going to be 115 degrees. So we want to do two things. So once we've constructed those exterior angles and we've solved what those exterior angles would be, we want to think about how does those exterior angles relate to the two opposite interior angles. So let's take a look at A, for example. So the two opposite interior angles for A, the two opposite interior angles are 65 and 40. If I take those and I add them up, look at that. It's the same as A. Does that work for all of them? Let's take a look. So let's do for B. The opposite interior angles are 75 and 65. And if I add those together, I get 140 degrees. Look at that. So the same thing would work for C, trust me. So what does that mean? It means that the two opposite interior angles will add to is going to be the same as the exterior angle, so that's important to know. And then what is the sum of my exterior angles? So if I take A and I add B and I add C, what am I going to get? So let's take 105, add 140, and add 115. So if I take those all and I add them in my calculator or use my mental math skills, I know that these will add up to 360 degrees. And we know that 360 degrees is the same as a circle, or the same as the interior angles of a quadrilateral. So that's important to note as well. So that's really helpful information for us to refer to. So the exterior angle is equal to the sum of the two interior angles across from it, and all of your exterior angles will add up to 360 degrees. Let's take a look to see if the same thing happens for a quadrilateral. So we're going to construct the exterior angles, and then we're going to calculate their sum. So I'm just going to extend these lines. I'm going to call this one A. I'm going to extend this line. This one's going to be B. Extend this line, we're going to have C, and extend this line, we're going to have D. Okay, so let's solve for A first. So A is 180, take away 65. Or A is 115 degrees. Let's take a look at D. So D is the same as 180 take away 105. Or D is equal to 75 degrees. Let's take a look at C. C is equal to 180 take away 80. Or C is equal to 100 degrees. But what about B? Well, B, we can first need to solve for this angle right here. Let's call this X. And we know that the angles inside of a quadrilateral is equal to 360, sorry. So X is equal to 360, take away 65, take away 105, and take away 80. So I'm showing you a slightly different strategy than I showed you in the previous lesson, so you have a couple of different strategies under your belt. So I'm taking 360 and I'm subtracting 65, subtracting 105, and subtracting 80, and that's going to give me 110 degrees. So now that I know what this interior angle is, I can solve for B. So B is equal to 180, take away 110, so B is equal to 70 degrees. And now that we have all of our exterior angles, let's see what they add up to. So A plus B plus C plus D. So I have 115 plus 70 plus 100 plus 75. And sure enough, those all add up to give us 360 degrees. So the exterior angles of a quadrilateral will also add up to 360 degrees. Unfortunately, we can't do that same strategy that we did for triangles, where the exterior angle is the sum of the two opposite angles, but we can use the same exterior angle theorem. So now let's take a look at these shapes. So these are not regular shapes, but here I have 1, 2, 3, 4, 5 sides, and a 5-sided shape is a pentagon. This is not a regular pentagon by any stretch of the means. All of our sides, they look like they are different measurements, so that's important to know. But let's see if our sides will be similar. So let's extend our exterior angles. So I have A, B, C, D, and E. So A is 180, take away 105. So A is equal to 75 degrees. B is equal to 180, take away 104. So B is 76 degrees. C is equal to 180, take away 118. C is equal to 62 degrees. D is equal to 180, take away 122 degrees. So D is 58 degrees. And E is equal to 180, take away 91 degrees. So E is equal to 89 degrees. So what happens when we add these all together? Well, A plus B plus C plus D plus E. Let's figure that out. So I'm just going to do all of these calculations. I'm not going to show you that step because I've run out a little bit of room. So 75 plus 76 plus 62 plus 58 plus 89 is equal to 360 degrees. So let's go through this last one. So I'm going to extend my lines to create my exterior angles. This one's A, B, C, D, E, and F. So A is 180, take away 99, which is 81 degrees. B is 180, take away 124, so that's 56 degrees. C is 180, take away 118. That's 62 degrees. D is 180, take away 103, which is 77 degrees. E is 180, take away 138, which is 42 degrees. And F is 180, take away 138, which is also 42 degrees. So now that I have all of my exterior angles, I'm going to add them all together. So I'm going to take A plus B plus C plus D plus E plus F. So 81 plus 56 plus 62 plus 77 plus 42 plus 42 equals 360 degrees. So what can you tell me about the exterior angles of any polygon? Well, that the sum of the exterior angles will always equal 360 degrees. So as I said, these are your formal definitions or your formal formulas. The exterior angle theorem, which we call EAT as a short form. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. So we can see that here. So D is your exterior angle, and D is the same as A plus B. So those are the opposite angles across from it. The interior angles of a polygon. So as I said, we can think about breaking this up into triangles, or we can use this formula here. So the sum of the interior angles of a polygon with n sides or vertices is equal to 180 times n minus 2. So let's use this formula to figure out this missing angle. We'll call it x. So how many sides does this have? Well, it has 1, 2, 3, 4, 5. So n is equal to 5. So that the angles inside of this shape is going to equal 180 times n minus 2, or 180 times 5 minus 2, or 180 times 3, and 180 times 3 is 540. So all of these angles inside here add up to 540 degrees. So what I could do is I could add them all up. So I'm going to do that. I'm going to take my x. So x is equal to 540. Take away 115. Take away 92. Take away 110. And take away 65. So 540 take away 115 and 92 and 110 and 65 is equal to 158 degrees. So that's a strategy and formula to refer to. So this sheet will be very helpful for you to add to your collection of formulas and theorems to refer to. And then the exterior angles of a polygon, which we discovered. So the exterior angles of a polygon will always have a sum of 360 degrees. So let's go through a few more examples. So we're going to determine the unknown value. So we're going to figure out what the measurement of each angle is. So we know that the interior angle of a triangle, or the, what we call it is the angle sum of a triangle theorem, states that x plus 2x plus 3x is equal to 180 degrees. So x plus 2x is 3x, and 3x plus 3x is 6x. So 6x is 180 degrees. I'm going to divide both sides of my equation by the coefficient in front of my x. 6 divided by 6 is x, and 180 divided by 6 is 30. So this angle right here is 30 degrees. 2 times 30 is 60. This one's 60 degrees, and 3 times 30 is 90 degrees. So that's how we solve for those unknowns. Let's take a look at our other shape. So I have a 1, 2, 3, 4-sided shape. So even though this is a bizarre 4-sided shape, I do know that the angle sum of a quadrilateral theorem or ASQT, states that all of these angles inside here will add up to 360 degrees. So I know this one, I know this one, and I know this one, but I don't know this angle right here. So this is what we call, this was our reflex angle. So how do I find out the reflex angle? Well, if I was to complete this circle, I want to take my 360 degrees and I want to subtract the angle on the outside, which is 90. So this angle right here is 360 minus 90, which is 270 degrees. So that's that reflex angle. So the reflex angle is 270 degrees. So now that I know all four angles inside of this bizarre quadrilateral, then I can solve for the missing angles. So I know that x plus 2x plus 30 plus 270 is equal to 360 degrees. So x plus 2x is 3x. 30 plus 270 is 300. And that's equal to 360. I'm going to move my 300 over first and subtract it. So I have 3x is equal to 360. Take away 300, or 3x is equal to 60. And now I'm going to divide both sides by the coefficient in front of my x. 3 divided by 3 is 1, so I'm left with x. And 60 divided by 3 is 20. So now I know that this measurement here is 20 degrees, and 2 times 20 is 40 degrees. So now we have example 3. So example 3 tells us that we want to solve for this exterior angle. Well, we know that the exterior angle theorem, so if we come back up here, exterior angles of a polygon tells us that these angles will have to add up to 360 degrees. So the exterior angles of a polygon theorem. So this tells us that x plus 100 plus 130 is equal to 360 degrees. So let's go ahead and simplify this. So x plus x plus 230 is equal to 360. I'm going to move my 230 over, subtract it. So x is equal to 360, take away 230. So x is equal to 130 degrees. And the last example that we're going to take a look at is example 4. We want to solve for the angles, or we want to solve for x. And we're going to first do that by solving for this mystery angle right here. Well, I know that these two angles will form 180 degrees. So 180 take away 140 is equal to 40 degrees. So this right here is 40 degrees. And now I know that this is a 1, 2, 3, 4-sided shape, which is a quadrilateral. I also know that the angle sum of a quadrilateral theorem states that if I add up all 4 of these angles, I'm going to get 360 degrees. So I have 5x plus 10 plus 8x minus 21 plus 7x minus 9 plus 40 is equal to 360 degrees. So I'm going to collect my like terms. 5x plus 8x is 13x, And 13x plus 7x is 20x. 10 take away 21 is negative 11. Negative 11 take away 9 is negative 20. And negative 20 plus 40 is positive 20. So I've just simplified my like terms. So now I can go by isolating my x. I'm going to first start by moving over my constant, and I'm going to subtract it because that's the opposite of adding. So if 20x is equal to 360, take away 20, or 20x is equal to 340. Now I need to divide both sides by the coefficient in front of my x. 20 divided by 20 is 1, so I'm left with x. And 340 divided by 20 is 17. So now this angle is 8 times 17, take away 21. And 8 times 17 is 136. Take away 21. So this one is 115 degrees. So right here, 5 times 17 plus 10. 5 times 17 is 85. And 85 plus 10 is 95 degrees. And this one right here, 7 times 17, take away 9. 7 times 17 is 119. Take away 9 is 110 degrees. So a way to check is if we take this 110 plus 95 plus 115 plus 40, sure enough gives us 360, which is what we wanted. So I hope that helps you learn some more properties to refer to, and then as a few more examples to apply those skills for interior and exterior angles.